Hi there and welcome to today's digital replay. We're continuing Unit 2, which is all about motion, and today we're on pages 336 to 337 talking about velocity. Velocity is a description of both the speed and the direction that the object is traveling. So the speed, again, is the change in distance over the change in time, and then a direction is the direction in which the object is traveling, north, south, east, west. In our example of the kitty high-speed car chase, our cat was traveling at a certain speed, which we can detect with a radar gun. That's our instantaneous speed, or the speed at which the cat is traveling at that moment. Because speed, again, is a measurement of the change in distance over the change in time. Now, if we add to that, say, a direction, like let's say the kitty cat is going, to Canada. Now we have a direction at which that cat is traveling. So this speed suddenly becomes a velocity, which is the change in distance over the change in time and the direction in which the kitty is traveling. We say that speed, which is distance over time with no regard to direction, is called a scalar quantity. A scalar quantity means that it has no direction. Velocity, on the other hand, does have a direction, and so we call this a vector quantity. If we take the example of the cart on the track, we can draw our position versus time graph just like we were doing in class, where the position is the centimeters and the time was in seconds. And the cart on the graph, moving in one direction with a constant velocity, had a position time graph that kind of looked like this, except maybe a little more straight. Now, if we wanted to then say, okay, let's translate this into a velocity time graph. So here's time on the bottom. And now we're going to have this be zero velocity. And this is velocity here, which is meters per second. And then time is also in seconds. And now we've got this velocity time graph here. The velocity of this position versus time graph is what we already talked about. It's the slope of this graph. Now the slope of this graph is constant. It's one value. I don't have any numbers here, but this is what it would look like in a velocity time graph. A positive line, a horizontal line in the positive part of the graph. This would be the positive part of the graph. This would be the negative part of the graph, above and below zero. So that's it. That's a velocity time graph. And that's not so bad when you're working with a horizontally moving, like an object moving in one direction that only has a constant velocity. But what happens when we make it a little more complicated? Like say this position time graph. So here's a position time graph, and let's give it a scenario. So we got this guy, okay? This guy is running to his class for a certain amount of time. That's this part of the graph here. At which point he pauses and he stops at the class where he is, realizes that he forgot his lunch, and runs back to his locker. Okay, notice that we've got some movement in the positive direction, we have a pause, then we have some movement in the negative direction. Now we learned a few worksheets ago that that the slope of the line is the speed at which the object is traveling. So what we could actually do is use this position versus time graph to calculate the velocity. So let's do that. The first part of the graph, we'll call that velocity 1, and we just use our equation for slope, which is rise over run, to find the velocity, which is 2.5 meters per second. Now let's do the second part of this graph, which is a little funny looking. But the second part of this graph is a horizontal line on the position time graph. So we do rise over run. There's no rise. It stays at the exact same position for 10 seconds, which means that our velocity is 0 meters per second, or not going anywhere. The third part of this graph has the velocity shown here. We do rise over run again, and look what happens. We actually have a negative velocity. See, now we have a speed and direction. negative 10 meters per second. That means we're going 10 meters per second in the reverse direction, or in the opposite direction. So we can build ourselves a velocity versus time graph using that data that we gathered in the last problem with the running guy. And the first velocity was 2.5 meters per second, and it was a constant velocity, so we draw a horizontal line at 2.5 meters per second. The second velocity, if you remember, was 0. He wasn't moving, he was just standing there for 10 seconds. And then the third velocity was negative 10 meters per second. This is our new velocity versus time graph. You see the three pieces of the graph don't look the same as the position versus time graph. That's because we're actually graphing the slope of that position versus time graph. Now we could get into the calculus of this and the crazy mathematics, but all I want you to be able to do is go back and forth between velocity time graphs and position time graphs and know what is happening and be able to describe it. This little animation here is called Running Man, and you can basically enter any velocity you want and make the running man run. So you can watch the little man up at the top, and you can change his velocity, and it will graph for you both the position versus time and the velocity versus time graphs. So you can experiment a little bit with what does it look like? How are these two graphs related? Now remember that the position versus time graph and the velocity versus time graph are related because the velocity time graph just graphs the slope of the position versus time graph. So each time you change the velocity, you're going to have a different value of slope, and so the position versus time graph is going to change. Now you can also change the direction by making it positive or negative, because again, velocity has a direction. Okay, so here we have Running Man again. This time, let's look at something crazy. Here goes Running Man. Now watch the velocity time graph. What is that? All of the velocity time graphs we've looked at so far have had zero slope. The velocity time, which is the red graph, has had zero slope, straight lines, horizontal lines. And now we've got this line with a positive slope, like the line is at an angle. What does that even mean? Well, watch the running man across the top of the screen. Watch what happens as he runs across the little plateau there. Did you notice that? Did you see that? He sped up. We'll find out why next time. Now that's a lot of information all about speed and velocity, but hopefully you'll be able to take from this that velocity is a speed with a direction and that velocity is a vector, and vector means that it has a direction. Now we can use position versus time graphs to construct velocity versus time graphs and vice versa, and hopefully you'll be practicing that on all the homeworks. Thanks for watching Digital Replay. We'll see you in class.